Thank you. Hey, everyone. Hope you're all having a good day. GM. Yeah. Hey, everyone. Okay, I'll share my screen. Will I? Where's my? There we go. I put the notes in Discord, so you should have those. And we've also got the third challenge in there as well, so you can have a look at that. So let's see where we are. I'll just switch to this. Okay, so yeah, we're quite a way through already. So we're going to talk today about zkOracles and decentralized exchanges. As usual, we'll start off with a quick look at any news, and then we'll just go through those two topics. All right. So, what's new? I didn't find much to say about the blog post that usually has details. Didn't have anything updated as yet. It usually, I think, updates just after I've done a talk. So maybe that'll happen in the next few days. But we've got details about the road to the upgrade and the what's happening on DevNet. So they were planning to do the final part on to start on the 14th. So that was a few days ago and run for a week, but that's been postponed. And then these are the tentative latest dates. So hopefully it'll go through. Though I think this not firm yet which days it will be, but hopefully they'll be able to get that through. We also had a new version for mainnet. There's a link there to the announcement. Yeah, it's this beta release, which has just happened. So if you're a block producer, etc., then you can upgrade. I upgraded one of my nodes for that. So yeah, that's what's been happening. Okay. So I'll go on then to the main topics today, which are I'll start with zkOracles, and there's quite a lot of resources out there about them. There's a video I've linked to, and there's a tutorial. I'll go through some of the tutorial today as well, and I think this topic was quite a strong use case for Mina, and it was one that has often been emphasized as one of the selling points for Mina, and it certainly makes sense that people would want zkOracles because there is the need for trustworthy data, and particularly given the focus that we have on DeFi and the amount of data that you need when you're interacting with DeFi, then yeah, the need is obviously there. And then we also need the trust as well, because we want to be sure that the data hasn't changed since it came from the data source, and that maybe the data source is trustworthy as well. Because a lot of, there are a lot of vulnerabilities, a lot of attacks that have happened because of Oracle manipulation and changing in, views of prices that aren't accurate, etc. So the idea behind this type of Oracle, I think the original idea was that we could write a zk app that would get any HTTPS data source or data from any HTTPS data source, and that Oracle would then be providing the trust, and it would then provide that to further apps on the blockchain. This has not been fully realized as yet, and one of the big advantages, I think, of this type of idea was that you could use any HTTPS data source, so it was going to be ubiquitous. It gave you, it was a very powerful idea that you could just do this, and also that the data source itself didn't have to do anything. There wasn't any work to be done on that side. As long as it was doing a secure connection, then that would be enough for all of the cryptography to make sense. So that's maybe the end goal, I guess, where we would like to be, but we're not. I don't think we're quite there yet. Similar to this, there's a project called TLS Notary, which I think may have come from Ethereum, where they may have had some input to it, which gives a similar idea. It's not. It's a more general project, I think. It's not particularly concerned with any blockchain. Yeah, but it needs one of the the idea is to integrate this. There was a discussion about this, and the idea would then be, if you wanted to try to integrate Mina with that, then you'd need to get the signature schemes lined up, because I don't think they are at the moment. Now, so that's a project outside Mina. There have been people who've tried to build similar things within Mina. There was a project, I think from cohort 2, called zkNotary, and they did a very nice write-up. Let me just check that link. They did a very nice write-up of how it all works. So yeah, I'll just show a little bit of that. They were talking about the idea that you would be using an API to get data from Twitter, and this would be the typical flow that you could go through. So the notary server would be there getting the data, and you could have an API getting that, and then within your contract you could have verifiers to check the signature from the notary server and check that the data hasn't been changed. And then once you verify that and you're happy with the data, then obviously you can go on and use that data. So here's the details of that. So we start up with Alice calling the server and specifying what data she wants from that. So it could be something like this from prominent person, and then the notary server can then set up a session, and so this is the point where we're using TLS. We're relying on that so that you can show that the data source is correct, and you can get the data from that, and then once you've done that and you've used the TLS session, then you can sign this for this data. And so this is the notary server doing it. This is acting as the oracle, and then the Alice can get the details from the oracle. The details will go back to Alice. She can then send this to Bob, who can verify the data that she has. And obviously, to do this, you need to be checking the signature that we've got from the notary server. So yeah, that's what that's about. And then obviously at the end you can parse the information out of that. Okay. And yeah, that should match up with the tweets that you had. Okay, so that was one project on Mina that tried to implement this. I'll go through the tutorial. There's one of the tutorial number 7 goes through generally how to create an oracle, and this is perhaps a little bit more limited. It shows what we can do at the moment anyway. And so what it is doing is creating the oracle that's going to get, well, in theory, you'll be getting data from a particular source, but what they actually do is they're providing the data within the oracle. But then it is signing that and with a key that we can verify on Mina, and then we can send that data back to any contract that's asked for it, and that contract can then check the signature, and we'll be able to get the data. There's the code is available there. You can try this out. If you can actually make a connection, they've got this running. So if you try to make a connection, you get back this. So it's showing within our data, we've got some specifics, because this is mocking the idea of showing a credit score. So it's coming back with an ID, credit score for that ID, and then you've got the signature and the key that's the public key that corresponds to the private key that signed this message. And so you've got enough here then to be able to check this signature, and you should recognize that's a Mina public key. I'm sure you do recognize that. So that's what we've got here. So yeah, it brings back the data, the signature, and the public key, as you could see. And then within the code, you can have a look at the code. There's a link to it, but I just brought out some pieces of that just to highlight it. So this is setting up the private key, and then so this is within the Oracle, I should say. Yeah. So this is setting up a private key to do the signing. Then we do this thing that creates gets the credit score, which is just mocking this thing up. But this represents our data source that our Oracle is using. And then we can sign that data. So this next part here is signing for these fields. So the user ID and the credit score, which is what represents our data. And then we signing with our private key, and that gives us our signature. So that's what's happening on the Oracle side. On the zk app side, we'll receive that, and then we want to be able to verify it. And so within the zk app, we store the public key of the Oracle, because we're going to be doing this multiple times, so it makes sense to have that stored. And then we're going to call a method to get and verify this, but within that we're going to specify the particular data that we want to come back. So that's why we've got the ID here. And then you can see that when we get that, we then once the data comes back, the signature comes back, we verify that by using the Oracle public key, that is the one that represents the private key that signed the data, along with the data itself that we are requesting. So we know the ID we're asking for and the credit score we're expecting, and then that valid signature variable then needs to be checked. So we then need to assert that is true, obviously, because we need to check what's come back. But once you've done that, then you know that has been signed correctly. So you've got the correct data, and then you could do other things, do other assertions on the data, whatever makes sense to you. Yeah, so that's what the tutorial looks like generally. So that's kind of just an overview of it. But if you want to have a look, I did provide a link to the code. Yeah, there, so you can go through all of that. There's also in the docs as well. Okay, so that's that tutorial. The other things that have happened, I think I mentioned this maybe quite early on, maybe session 1 or so. There was this RFP that came out asking for zkOracle integration, on JS, and they had this diagram that they were to explain how it would all sort of fit together. So you're going to develop the zk apps, which will then be able to go to an Oracle, but to use an SDK, so you can request data from that. The Oracle themselves will have integrations to useful data sources such as social networks, or maybe Web2 data providers as well. And I think this idea of the Web2 data provider is the idea that a lot of people had, that the use case we were going to use generally, and so that can then produce data and send back proof that this has been taken correctly from these different integrations, and then your app will be able to verify that proof, or send that proof on to Mina, etc. So that was the idea. No, where are we? Let me go find the link. There were a number of proposals, so if you're interested, you can work through. You can have a look at some of these. People sort of explained their ideas and how it would work, because they've got some nice sequence diagrams here. Yeah, you've got details of the different people who could get involved. There's quite a few projects, and they do go through and explain exactly what they are thinking of doing. So yeah, further diagrams here. So if you're interested, that may be useful for you as well. Okay. Another project I came across that was from, I think maybe this was cohort 2 as well. I can't quite remember, but this is the Doot, I think if I pronounced that right, the Doot Foundation, and they're acting as at Oracle. They're providing data. This is an overview about them. So they go to various exchanges and bring back data, and they have so they have cron jobs running to automate this and to go off and get back data. They also, I believe, they have a sort of a mix of sort of current prices and then historical prices as well, and then they put the details of that in JSON format into a file, which then goes on to IPFS. Yeah, so that's them. They've got, let's go through this, show you this getting started. If you're interested in getting this data, you can sign up. So you go to their site, and go to the dashboard, and you can sign up. And they ask you to sign so that they know then that requests are coming from a particular key, and then they'll give you an API key that you can use, so you can have that. And then they've got some examples here of the code that you could have in your contract when you're interacting with their oracles. And here you see the particular assets that they are they're providing. So you're getting prices of Mina, ETH, Bitcoin, Link, and Sol. So yeah, here's the idea of you need to set up a client and have an environment variable which holds the API key, as you see there. And then you can request the price of a particular asset from that. So once you've done that, you'll get information back, which you can then decompose. So you can get back for a particular asset, the price, number of decimals, and then you need the signature and the oracle, the public key from the oracle, so that you can do this process again of checking that this has come correctly from Doot, and you can check their signature, etc. So you can verify all of that. Okay, so that's that project. One that I spoke about, I think, in the last session, because this, I think, had just come out, this blog post, but it says it relates to Oracle, so I wanted to put it into these notes as well, so that you got everything together. And that's this DIA data. There's a link there to the blog post, but it's a proof of concept. But they're using zk circuits to check that the computations are being done correctly, and also the computations that are enriching data, I think. So they're taking data and then producing sort of more complex or sophisticated results from that. They also have the idea that they're interacting with a number of data sources, and they get back metadata, and then they can do analysis on that metadata, which allows them then to give an indication about the reliability of the data sources. So quite an interesting idea there. I haven't seen that elsewhere. I don't know how reliable that is, I guess, or how useful that is, whether they can genuinely get a good idea. But yeah, so worth having a look at anyway to see if that's possible. Okay, I've gone through that fairly quickly, but that's a general idea about zkOracles. So just to recap, I guess, to go over sort of the main points, that we're not quite where we would like to be. It would be great if we could quite very simply just go to a HTTPS data source and use that as an oracle, but there are projects that can help with this, and so I showed you some of that. within the tutorial, you get a general idea of the kind of flow that you need to go through if you're creating an oracle, in that or you're creating an oracle, and then also if you're interacting with the oracle, because the oracle itself needs to get the data, sign that data using a Mina signature. So yeah, using a Mina private key. You can then send that signature and the data to a zk app, or the zk app can request that. And then on the zk app side, you then need to be able to verify it. And so you see the example here where you're verifying the signature and obviously asserting that that is true. And then you can go on and use the data itself. Okay, so yep, that's that. Oh yeah, I just forgot to say that on from Zoot as well, they have some example code. If you want to have an idea of how to interact with their oracle, they've got this example code here where, so this could be for a zk app. So maybe your app is storing some prices. You want to keep track of various prices. So you have this method here that's going to update the prices. Obviously, you have to check the preconditions, and then when you're updating the prices, you're getting the data from the oracle and the signatures. Then you can verify those here. So you're verifying the details against the oracle signature and checking that that is true. And if that is okay, then you can set the price that you're keeping as your state in your zk app, as you can see there. And they've got some exchange rates as well as prices. Okay. So yeah, it's an example there of interacting with Doot as well. So I think they've got a couple of examples if you want to try those out. Okay. All right. Hope that all made sense. It was clear. It's worth going through the tutorial and getting an idea from just trying that out and getting an idea of the flow as well. All right. So let's move on then to the second part, which is I wanted to talk about decentralized exchanges, and it brings us back to one of our main themes in this program, which is that of decentralization, and very much the benefits of decentralization, and how Mina is really ideally placed to provide some of these benefits. But what I'll talk about first of all is just general ideas around decentralized exchanges, because they've been used on other blockchains and people have got some experience with them, and these exist in many chains. First of all, to sort of show why we need them, if you think back to when sort of crypto was much younger, if you wanted to deal in crypto, if you wanted to buy some crypto or sell it, then you were really forced into, well, either you could mine some yourself, or you could sort of trade it with someone locally. And if I'm thinking of Bitcoin here, there was possibilities of doing that, but otherwise you would have to go to a centralized exchange to buy whichever cryptocurrency you were interested in. And this obviously was not a great situation, and so we've always wanted to be able to have decentralized exchanges. And there's been plenty of examples of centralized exchanges going bad to some extent, and maybe that's because they've been hacked, and therefore their funds get lost because of that, or maybe they're bad actors themselves and they steal your funds. But whatever, one of the big advantages to decentralized exchanges is that you control your funds, and the big advantage to decentralization generally is that you control funds or data, whatever it is. But that's for me certainly, it's a very powerful argument for decentralization. The second point here about anonymity is interesting, because obviously, well, not obviously, some chains they think they are anonymous, but there's a kind of a limited, this is kind of a pseudo anonymity that they have. But certainly much greater than that is the fact that if you go to a centralized exchange, they are going to expect you to go through some KYC procedure. They're going to want to know who you are in the real world, and there's very little, very few ways of getting around that. So yeah, they're certainly not anonymous, and they can once you start to interact with them and then use addresses and you have transactions involving centralized exchanges, then obviously that information about you is going to potentially leak then onto whichever chain you're working with. I talked about hacks, but this next point is true. Centralized exchanges have been around for a long time. They've been working in traditional finance, so they've had time to produce very slick products. But also, writing centralized software is often easier anyway. And so the centralized exchanges do tend to be easier to use than decentralized ones. And decentralized exchanges have really suffered from the user experience, and it's been difficult for them. It's been difficult to use them. And we'll come on to a couple of reasons why that is. But I think part of it is the general process that, or the general problem we have in Web3, that we're still not good enough at providing a good user experience. Similarly, centralized exchanges will have advanced trading tools, all this kind of thing, whereas decentralized exchanges tend to be much simpler, have much more limited functionality. And one of the big problems with decentralized exchanges is around liquidity, and this certainly affected the first attempts at decentralized exchanges that were made. But one great thing about them is that they have this kind of democratization, because until decentralized exchanges came about, if you'd created your new token, your version of Dogecoin or whatever, and you wanted other people to be able to buy it, you wanted to be able to sell it, then your only option was to get that listed on a centralized exchange, and they would charge you a lot of money to do that. It was in the millions of dollars were being asked to get tokens listed on the big exchanges, and also obviously they had complete permission about that. You had to ask them to do that, and they had complete control over whether that was going to be done or not. So when decentralized exchanges came along, it was a great sort of freedom that we had, that we could create our vanity tokens or whatever they were we were creating, and then immediately get those added to a decentralized exchange. And there was no one that you had to ask, there's no permissioning involved, and there's no cost involved other than the cost of the transactions. So massive benefit there. The initial exchanges, they had problems though, because the way they worked, they would require a buyer and a seller to effectively to create the trade, to come together to create a trade. But that, particularly if there was low liquidity on a particular pair of assets, then that could mean that if you wanted to sell your vanity token, you could be waiting a long time for someone to appear that will want to buy that, and that is going to again be quite a bad user experience. And that's really exacerbated by if there's low liquidity. Okay. So this all improved when we got the idea of automatic market makers. And these, so market makers are people who are there to provide a market. They will buy and sell the assets on a particular exchange. And the automatic market makers are a way of doing this in smart contracts. So they'll always be available. They will always be able to provide a market. So whatever token you have, in theory, you should be able to do a trade on that. I mean, there may be that there's not enough liquidity, but in theory, you should always be able to do that. And this is done via pools of tokens, and users will put funds into these pools, into liquidity pools, and then once those tokens are in these pools, then other users can come along and swap one of the tokens for the other, or provide one token and get the other one back, and do more complex interactions as well. So the people who are swapping the tokens, they are seen as taking liquidity from the pool, and so they are then expected to provide a fee to do that, and the fees that come from all of the people who are doing the swaps, all of those fees then go to the people who provide liquidity. So so there's two kind of functions that you have then. So some people will be going in to provide the liquidity and will be adding both tokens into the pool, and then other people are doing the swap. If you've provided liquidity, when you come to redeem your tokens at the end, then you will get a share of the fees that pool has earned. Now, the way that this can be done automatically, and the way that we can work out the price for the assets in the pool, is by a thing called a constant function, and these things are called constant function market makers. And the algorithm or the rationale behind that is that when you have one of these pools, you will have a certain amount of each of the tokens, and what the algorithm tries to do when it's working out the price, the effective price for a token, is it tries to keep this ratio constant. And so the tokens in the pool, that's called the reserves, and so we have this idea that they're the product of the two reserves in a pool is going to be constant, and this is sometimes referred to as XYK, because they think of X and Y being the number of tokens in a pool, the reserves, and then that's going to be equal to a constant K. So you might see that terminology around. Okay. If I'm sure you've seen these things. This is Uniswap, an example of swapping. So you can pick a particular token and swap it for another token. As you enter the amount you want to swap, it will come back with a price that you should receive. What it effectively is saying is, when I'm talking about price here, I'm effectively saying, how many tokens am I going to get back when I do this swap? So that looks like, if you're adding liquidity, you're providing both tokens. So here, there's an example, you're providing ETH and Uniswap tokens, and then that's increasing the reserves within the pool. This was done very simply initially, and then as these exchanges became more sophisticated, we got this concept of concentrated liquidity, which means that when you add the liquidity, you're adding it to a certain price range, rather than it applying generally to any price within the pool. So that's why it's called concentrated. It's concentrating the liquidity around certain prices. And so, yes, you may see that as well. But that's that was a later version of Uniswap, for example. If you're adding liquidity, what will happen? You're adding both tokens, and then in return you receive things called LP tokens, liquidity provider tokens, and this really is to show that you have added this liquidity to the pool, and it allows you to later on redeem the tokens that you added to the pool, and hopefully you'll get more back than you put in, because you're getting the results of the fees that people have paid as well. So hopefully you will make a profit out of doing this. There are other ways that this has been done. So Uniswap also then moved to using NFTs, rather than using the LP token. So the LP token was a standard ERC20 token, and then Uniswap moved to use NFTs to show that you had provided some liquidity. So that's something else you may see. And there's an article there, sort of intro to AMMs as well. It's quite good, and it shows you some of the or gives you some of these terms that you will come across when you're interacting with a DEX. These particularly show some of the problems you will get when you're doing a swap. But there's subtle differences between these things, so it's worth understanding these. So when you do a swap, that will make a change to the price of the tokens that are the tokens in the pools, and that's how how we get this constant function working. But what that means is that if you try to do a large transaction, if you try to do a large swap in an exchange, that could substantially change the price of the token. So you may go in thinking that you would get a certain price, but if you then try to do a swap for a very large amount, then you may find that you're not getting back as many tokens as you would like because the price has moved. But that price impact, that's just really to do with the transaction that you are doing and the impact of the volume that you are trying to take from the pool when you're trying to get some tokens out. Another term you'll see is slippage, which is a similar kind of idea, but it's the fact that in the time that it takes from you sort of seeing a price and sending off your transaction to when this actually is executed and you get some tokens back, there could have been a movement in the price because other people could have had their transactions executed ahead of you and they could have changed the price. So this is likely to happen generally. There will be changes in the price all the time. But what usually happens with DEXs is that we want to limit the effect of this, and so when you're doing a swap, you can usually specify the amount of slippage that you're going to tolerate, because it could be that you would be happy if you got back 100 tokens, but if you got back 95 tokens, that wouldn't be worth your while. So you can specify usually a percentage that of the price change that you'd be happy with, and if it exceeds that, if the price changes more than that, then the transaction will revert and you won't do the swap because it may not make sense at that particular price. Okay. Now another or a less tangible idea or concept is this idea of impermanent loss, where it's usually, we're talking here about when you've provided liquidity to a pool. And then, some later time you come to withdraw from that pool, and you're hopeful that you're going to make a profit. But what actually happens is, for whatever reason, you get back less, or the value that you get back, the real world value of those tokens against some, say the dollar, is worth less than when you provided those tokens. And so there's been a loss over time, and this loss is really characterized as compared to the loss if you just held the tokens. If you hadn't used them to provide liquidity, what value would you have at this point? And the graphs have been done to show this, sort of how this will change as the different prices of the tokens change. And so this gives an idea where here the 100% is where you're going to get you're back the amount that you put in terms of value, and then the purple line is showing the difference from that. Okay. But what sometimes happens is the people who have run these projects may provide other incentives. They may give you stable coins or some types of yields and rewards to try to mitigate against the impermanent loss and try to keep people providing liquidity. The other thing that may help as well is that within a liquidity pool, you don't necessarily have to start the pool with a sort of an equal ratio, and so you can have different ratios being maintained within the pool, and so that can also help reduce the impermanent loss. Okay, let me just have a drink. I think we're okay for time. So that's just a very quick idea of the standard idea of what a decentralized exchange looks like using an automatic market maker. But that's not the only way that we can do trades. And the traditional way that it was done, in TradFi, we had we used to use things called order books, and initially these were not really seen as feasible as in a decentralized way, but people have started to implement these, um, and the general idea behind them is that it allows more sophisticated ideas of trading, and rather than sort of submitting a trade and getting back just what you can at that time, you can submit a limit trade. So you're looking for a particular price, and then the trade will execute only when that price is reached. Um, so there's this idea of matching orders. It comes back really to the idea I was talking about when I talked about the initial decentralized exchanges, where I said you had the two sides and they were waiting to be matched. So this is the same idea, that there will be a matching engine which can match these orders. This is much easier to do in a centralized system. Obviously, you can just have some process running, a matching engine running that will do this for you. But it is also possible in decentralized systems as well. Excuse me, but uh, they're still not necessarily as good as centralized systems, where again we typically see them having lower liquidity, and the performance tends to be lower with decentralized systems generally, I suppose. But yeah, you will see some of these also, and sometimes you get a mix. You'll have an exchange that provides a mix of these. Okay. Just wanted to mention an aspect of DeFi called composability. The idea behind that is that uh, it it allows us to be quite creative and to create new financial products by putting together a number of systems or a number of projects, and we're able to do this because of the standards that people follow with when we think about things like tokens. And so you'll often see this idea that you put together different DeFi applications. So maybe there'll be a DEX and maybe some project that allows you to borrow tokens, another one that allows you to do some sort of farming, and you can sort of link all these together to make sort of a composite product that you would find useful. There's an article there if you want to read more about it. But again, the great thing with this being decentralized is that you can just build these things yourself. There's no one else controlling this, and it certainly helped DeFi establish itself. Where when we had the summer of DeFi a couple of years ago, and there's a huge growth in the systems, and these types of ideas really helped the whole ecosystem. That's on the plus side. On the negative side, there are risks involved with this. And there's really kind of a systemic risk. When you start to join these projects together, then if one of them fails, then that failure could spread to other ones. And that could be, for example, with this example, where the price of Ether dropped dramatically, and that led to people doing something in one system, and then that led to oracles being late, which then led to liquidations happening on borrowing platforms. You also see this with when there is hacking going on, and a particular protocol loses a lot of tokens, or a lot of tokens are stolen from a particular protocol, and then this could have serious effects on the ecosystem as a whole, because it often leads on to liquidations because it affects the price of tokens quite considerably across the system, and so it has a very large knock-on effect. So yeah, that's the downside to this idea of composability that we have. Other problems, I mentioned liquidity, and early DEXs certainly suffered from that. That was helped by AMMs, because then we had something automatically providing liquidity. As long as there are tokens in the pool, then there will be some liquidity available. Although you end up getting a very prohibitive price. but yeah, so that has improved to some extent. Also, what happened with early exchanges was this idea of coordination, which we'll see again later, actually, in the notes. But the fact that the participants have to be interacting sort of together to or to collaborate to produce a trade. So that's a bad user experience, and it means that you can't use these systems very quickly, and you can't automate things too easily. Another problem you may find is around the lack of standards or doing things in a non-standard way, because the standards that we had with tokens has really helped to develop the ecosystem and meant that if you're building an exchange or a wallet or whatever you're doing, you can make assumptions about how tokens are going to behave because you know that they're going to follow a certain standard. So that makes your life a whole lot easier. You're not having to write custom code to sort of think of every eventuality that the token could have. But not everybody then follows these standards or the conventions, such as the number of decimals that a particular token will have. Although there are conventions around that, some tokens sort of use different amounts, and that means then when you're interacting with these exchanges, etc., then you have to take note of that, and that can increase the amount of code you need to write. And it can be quite frustrating. Similarly, some tokens don't follow the standards exactly, and I think some of the stable coins do things slightly differently. So that also can produce problems. So that's another drawback. And then privacy, because a lot of the DeFi we've seen so far has been on public chains like Ethereum, and so everything you're doing is going to be public. And this not only means, well, there's a couple of problems with this, I guess. Not only does it mean that your transactions are being seen and can be seen, so you're losing your own privacy, but also this has helped with the rise of things like MEV, where people are looking at transactions in a mempool and then using that to extract value from the system. So we don't see privacy very much at the moment, but that's obviously where zero knowledge systems are going to be useful, and where Mina could really help out, because we could be used to provide some privacy. And we have had other things, other systems as well, trying to do that. For example, you had Aztec that did sort of took the ideas from Zcash and then developed that for more complex financial products. There's also an interesting one, Renegade, which they use collaborative snarks, which is one of the few use cases I've actually seen in the wild of that. It's quite an interesting area of cryptography, and the Renegade are using it. They're building a dark pool, and then within this dark pool, the users can't see what other people are doing. That's the point of a dark pool. You're not aware of all of the liquidity, etc. But you still need to be able to check that the trades are being done correctly. And to do that, they have multi-party computation happening, and that's combined with snarks to create proofs that it's all going correctly. So quite an interesting project there. Okay. So those are some of the problems that you may see. Let me just close some of these tabs because we've finished with them. Yeah, we've got through those. Okay. So if you are, I want to talk now about some of the information you might want if you're, say, building a DEX or you're interacting with it. So really the minimal type of functionality that you tend to see would be to allow a swap to occur. So that will be where a user supplies one token to a pool, and then they get another token back in exchange. Also, we need, if that pool is going to work, we need to be able to add liquidity to it. So that's where you're providing both tokens, and then you get something, LP tokens back, or maybe an NFT that indicates that you have provided liquidity, and you can remove that later, which is the third point here. You can remove liquidity and you'll get your original tokens back. So those are the very basic things that a decentralized exchange would want to do. But over time, people have created much more sophisticated exchanges. And for example, there is interoperability and interaction between exchanges, which allow you to say go to an exchange to do a swap, but then the exchange will help you by trying to get you the best price by looking for prices on maybe other exchanges, or maybe by doing multiple hops between pools. It may be that rather than going directly to one pool, if you do go through multiple pools and multiple tokens, that you will get a better price for your original swap that you wanted to do. And so these are the sort of extra sophistications that some of these exchanges will have added, and there are others as well. And as I also said, we've got the idea of the order books as well that some exchanges provide. But obviously with Mina, we're still very early days, and people, the types of systems people are building are really concentrating on some of these simpler ideas initially, I guess. Okay, so if you're thinking of building something like this, what kind of thing do you need to do? Well, what sort of architecture, what objects do you need? Well, you're going to need a pool. You're going to need a number of pools for your tokens, for token pairs. By default is you have 2 tokens, but you can have pools of more than 2 tokens. The pool will need some kind of identifier, and I think this is generally done by taking the symbols of the tokens in the pools and sorting those, hashing the result, and then that gives you an identifier for the pool. So there's just a sort of simple algorithm that people tend to use for that. So that's providing pools, and then within the you also need something like what's called a router contract. This tends to be the interface that users see when they're interacting with the exchange, and this router contract, you will call methods on that, and then that will pass the transaction, or will find the correct pools and sort of continue the transaction there and actually do the swap for you, and hopefully return you some tokens at the end of it. Now, so that's very much the basic some basic blocks that you would need if you're building an exchange, and we'll look at some particular exchanges in a second and see what they've done. One interesting point one interesting thing we tend to see in zero knowledge systems is that they often use a UTXO approach. So when Bitcoin came out, it had this the way it held balances really was what is called an unspent transaction object, and it was perhaps not a completely intuitive approach, but if you want to sort of think or have a mental model of it, it sort of correlates quite nicely with the idea of physical banknotes. The idea is that a particular user will have a balance of, say, Bitcoin, but that will be represented by a number of UTXO objects, and these will have various values, and then when you want to send these to someone else or buy something, you can combine these together, and then these will be, if they are spent, then they will be marked as spent, and you will spend some of these, and then maybe you will get some other ones back. It's like getting back some change. So if you provide, say, 100 in value, but the thing you want is only worth 75, then a new UTXO object will be created for you worth 25. So it's like getting back some change. So that was the kind of the model that was used by Bitcoin, and it seems to have been followed through and become maybe a standard or sort of a convention, at least, for other zk systems. So when Zcash was built, I mean, that was really much built around the Bitcoin systems, but they use this UTXO approach. And then other projects seem to have sort of continued with that in other zk systems have continued with that, and that is opposed to the approach we have in Ethereum, where we have a balance. So you have a particular account, and that account has a balance associated with it, which is more like having a bank account where there's some database somewhere which associates your bank account ID with some balance. The UTXO approach is more like a physical banknote. Okay. All right, so let's have a look at some example dexters on Mina, or up and coming ones anyway. So the first one I'll look at here is called Lumina. This is just a screenshot taken from their page. There's links there to that and to their paper, and it's well worth having a look through their light paper. There's lots of useful detail, and I'll be going through a little bit of that in a second. It is being built as a as a roll-up, I think. So I think the approach that people are taking generally is that things like this are going to be difficult to implement sort of directly on Mina L1, and so we're looking then to have these things built on an L2. So we looked at one of these in the last session where we looked at ProtoKit and the fact that could be a layer 2 for Mina, and Lumina is doing a similar thing. And they have these are the basic operations that you are able to do, and this diagram shows sort of how these fit together. And again, this has used a UTXO model. So you can start off with some assets on Mina L1, and then you can get those deposited onto the layer 2. So this is your entry into the system. And this they've got this thing here to say this is the privacy layer here. So this is where the privacy starts. So this gives you a UTXO. With that, you can create a swap and then execute that swap. There is this concept that they've got this idea here of partially filled orders. I think the idea behind that is that you could be doing this with multiple UTXOs, and so it could be that some of those are then swapped and some are left. Also, you have this idea of the change in the deposit UTXO. I think this is giving you back some change if you need it from your deposit. And then but eventually hopefully your swap will execute, and then you will have some UTXO representing that, which you can then withdraw if you like, and then exit that and get that asset back onto the layer 1. Okay, so that's I think an idea of the most basic way that this can simply work. Now, one of the problems, one aspect of this, if you want to do this, is that if we're thinking about doing this if you're thinking about doing this on Mina, you're doing things off chain. So the user here is going to be creating proofs in this process as they are doing this transaction, which may not be ideal. And so they've suggested that there could be other actors introduced into this who are relayers who will provide a proof for you. But when you start to do that, and I think generally if you open up an area and allow other people to come in and get involved, then you have to start thinking about the incentives to make sure that they are doing their role correctly and not doing anything malicious. And so there is, if you do use relayers, this does add extra complexity to the process. Now, another point is the idea of pool operators. So in addition to the idea of creating just a normal pool that anyone can use, they also have this idea of having pool operators who can set up permissioned pools, and they are doing this because of requirements around things like KYC. So this this gives you an idea of that. Also, as well as the automatic market maker type of pool, we also have the idea of having an order book as well, so that you could be creating one of those. But then you're asking here, do you require KYC? And then if not, then you could create a public pool which is completely open. But if you do, then you can create one of these permissioned pools instead, which will have a pool operator that is involved with the KYC and could be involved in other things. So be looking at the transactions and looking at the jurisdiction of those and whether there are problems with that, and therefore transactions shouldn't be allowed to proceed, etc. So that's the idea behind the pool operators. This is an example or some pieces of code that you would from their system. So this is to create a swap, and you'll see here that we have this idea of commitments and nullifiers, and this very much ties in with the design of systems like Zcash and Aztec, which are based around the use of the UTXO objects. And the way that they are used is that you take if you want privacy, you will take these objects and you will create commitments to them, and that the creation of a commitment to the object rather than the object itself allows you to obfuscate details of that object, to give you some hiding in the terminology of commitment schemes. Now, another aspect that you want when you're doing a swap is, or doing any spending a transaction, is you want to make sure that there's no possibility of a double spend. And to help you with that, you have the concept of nullifiers. And these are deterministically created from details of the UTXO, the original UTXO. And what the system can do is when you're doing a swap, or when you're sending a transaction, is to create one of these nullifiers, or sorry, the person who has control of the UTXO will be able to create the nullifier because they know the details of the UTXO they have. That nullifier then becomes added to the system, and the presence of that nullifier shows that that particular UTXO has been spent or swapped. But the way that the details in that nullifier don't allow people to go back and work out which particular UTXO that belongs to. So there is a kind of breaking of the links between the original UTXO and the nullifier that shows it has been spent. But if the person who creates that UTXO tries to spend it again, then the system can detect that that is happening because of the presence of a nullifier, and then that will be stopped. So the nullifiers are a very useful pattern, and I think I spoke about them a couple of sessions ago and spoke about the use of the nullifier pattern. But it allows us to ensure that the system is operating in the way that it should be, but it breaks the links between say certain accounts, or it also helps to obfuscate details of these notes. So it's a very useful pattern, and it is widely used, for example, in Zcash and Aztec, and as you can see, it is used here as well. And then here we've got the details of doing the swap itself, and you can see we've got two participants, Alice and Bob, as usual, and also there's a possibility here of having relayers as well, as I spoke about a little bit earlier, and so that's part of the execution. It's one point about this is, I think, yeah, it says at the top here, they need to do this collaboratively. So you have these two actors involved who have to then provide these things together, and so you do need to make sure that these swaps are relating to each other. And there's other details that are being checked here as well, as you can see in the comments. such as creating nullifiers, which you could check. Just going back to the architecture, the standard way of doing this and holding UTXO objects and holding nullifiers is to put things into Merkle trees. It probably won't surprise you that's a standard way of doing it. Okay. This point 6 here, this is where you may need to provide some change. So if you have a UTXO that hasn't fully been used, you may need to create a new object to represent change from that, and then that gets returned, or also you can maybe using that for fees. Okay, so that's a little bit of an idea of the code. If you look at the paper, it's got quite a lot of detail. It's quite nicely written, so worth having a read. There's more details than I've been able to go into, obviously, but there's lots of details there, and also it explains nicely how the whole thing works. It's got so state transition diagrams as well. So well worth a read. Also, there was the announcement they've joined forces with I guess it's called zkO, which I'm not sure how much I spoke about this before, but a similar idea to ProtoKit, providing a layer 2, and there's some links there to both of those. Okay. All right, so another DEX that is being built is the Cowpan DEX. Hope I pronounced that correctly. This came out of, or is built on top of ProtoKit. So they're using ProtoKit as the layer 2, and this is still being developed. I mean, they're part of cohort 3, I think, and they're looking for further funding to further develop this. This is a screenshot from their demo. If you want to try their demo, you can try it out. It gives you an idea of what you see. So you're providing some Mina, and you're wanting to get back an amount of DAI, the stable coin, and this is showing the suggested price here. But I think I pushed this to the limit of the amount of DAI that was available, so it was perhaps not getting such a good price. But anyway, that's the UI that they've got to give you an idea of what it looks like. And they are sort of building this further, so they're providing the AMM. I think they also want the idea of an order, or we ought to be able to provide an order book as well. These details here came from their proposal, so I'll just talk through those. I mean, they know best about this, so I think it's appropriate. As I say, it is built on ProtoKit. The fact that it's built on ProtoKit allows bridging to happen between the layer 2, or between the DEX and the layer 1 then. So you can get tokens being deposited because we've got this mechanism already there from ProtoKit. These bridging contracts already exist. Obviously, we've already got all of the zk architecture available on ProtoKit, and we've got the way ProtoKit works. There's this modularity that they have, where you can provide, you can customize your layer 2, and decide how the sequence is going to work, etc. So they've got that available also. So the way that they get privacy involved, if you remember from the last session, I spoke about how ProtoKit works and said that the sort of most straightforward way of using it is not necessarily involving privacy, but there are ways that you can do that because they have a hybrid execution model. So you can do your execution in a transparent way with no privacy, but you can also do execution that will involve privacy by doing some off-chain execution, getting a proof from that, and then providing that to ProtoKit and having that verified. So that's their hybrid model. Again, they've gone for the UTXO style, or the basis of their architecture, and their putting the objects, the commitments to the UTXO objects into Merkle trees, similarly to how Zcash work. These are append-only Merkle trees. So what this means is that as you create these objects, these get added to a Merkle tree, but you never remove them. And similarly with the nullifiers, these will get added to a Merkle tree for nullifiers, but they won't get removed. They've got an API that you can interact with. Obviously, because they're attached to a layer 1, then you get the security from that. That's the sort of basic thing that you get from the layer 1. But also there's all this extra processing you can get with ProtoKit that allows things such as indexing of the transactions and the data that is there as well. So there's a lot of data enrichment that can happen with that. Okay, the way that this is represented, this I've taken from their notes as well. The idea that they have this routing, so this means, as I said earlier, the idea of doing multiple hops through different pools to give you a better price. So that's what they are looking for as well. Yeah, so that's what they have the API for. Okay, how do I do it for those? These are some diagrams to illustrate that. So I need to. It shows you the flow to some extent. So you start with the user. You can deposit funds. That is going to go. You're going to deposit onto the layer 1 into a through the bridge contract, which will then credit you with funds on the layer 2 on the exchange itself. And then within that, once you have those funds available to you, you can decide to, maybe you're going to provide liquidity or you're going to do a swap. So this will mean you interact with the router module, which is the sort of the common way that you interact with DEX, as I said earlier. And then this will then sort of do the interaction between, involving particular pools, as you can see here. So maybe that would be, if you want to swap A to C, that may involve the router module making the decision for you to go to a pool to swap A to B, and then to another pool to swap B to C, and then you will get back the C tokens as a result of that. Okay, so that's a typical flow. And then they've got the idea of doing an order book, which is, I guess, more complex. But again, you have this idea of you depositing funds onto the layer 1, and then they are bridged onto the layer 2 and into the exchange. But then, it's a little more complex. You have this account state which can be encrypted when you start to post the order. You have this idea of a matcher trying to match orders together, and this will result in these UTXOs being matched, and maybe then they will be effectively filled, or maybe there will be extra UTXOs created from some things that are partially filled, or from change being produced, or from to provide the UTXO that's going to go back to the recipient of all of this. So a little bit more complex there. Okay. Yeah, this is just to show the routing idea. So starting with your externally owned account, when you are doing a swap, the way that you can do that, you do have some choice in that you can, when you provide tokens to the exchange, you can specify the amount that you're providing, and then you can say, well, just give me back as many tokens as you can of the other token. Or you can do it the other way and say, well, actually, I want a specific number of tokens back, and then you will provide that many tokens as a result. And so that gets calculated in different ways, as you see here. Okay, and let's make that smaller. There's some example here of the code that's involved, so you can have a look at this in their repo. But it's an example of this one is calculating the amount of tokens that you would get back. So you pass in the IDs of the tokens that you want to swap, you pass in the amount that you're providing, and then it gets the relevant pool, it gets the reserves from that pool, and then it can then calculate using the ideas behind the constant functions, etc. You can then calculate how many tokens you should get back, which is what this part here is doing. Okay. This buy, I think it's called, I think this is, I think this may be when we're adding liquidity. I'm sorry, I can't remember now, but anyway, yeah, there's some more examples. If you have a look at I think I provided hopefully I provided the link. Yeah, I provided a link to the repo, so you can have a look through the code and sort of look how they do that. Okay, I think that was pretty much it, except for they've also got this point about staking. I think maybe Lumina are doing something also, but they will delegate tokens that you have deposited, and then there's some sort of governance mechanism going on into who they get delegated to. Okay. All right. So that's pretty much everything. I hope I think I'm on time. But that's all I wanted to say there. I just want to talk about the challenge. So I'm sorry this is a little bit late, but you've still got reasonable time to do this. You've still got a month to do this. So the details behind this, we're familiar with our Mina Spy Master. He's been trying different approaches to processing messages, but what he's come up with now is that he wants to try out ProtoKit to see if that will be able to process us, or you can use that as a basis to build a system on which to process his messages. And so what you need to do for the challenge is to create a ProtoKit project, to create an app chain that is going to process messages, and there will be one message per transaction. Within each message will have a message number, or similar to the last challenge, and then it has some details, a little bit simplified compared to last time. We've got an ID of the agent who is sending the message. We have the details of the message itself, some 12 characters, and then there's a security code, which is a 2-character code that we can use to check that this came from the correct agent. Now, the way that we do that check is that we hold state, which has details of the valid agent IDs that will be sending messages, and then against each agent ID, we will have their security code. So we need to be able to find that agent ID and get the security code and check that that matches with what we see in the message. In addition to that, you should be checking that the agent ID exists, that in our system, so it's a valid agent ID. We want to know the last message number that was received from that agent, and the security code, as I've just said. And you can assume that this has been populated at some point previously, so you don't have to think how that will be populated. Just assume that this exists already, the data for that already exists. So when you receive the messages, you need to check that the agent ID exists. So we've got a valid agent. We need to check the security code for that agent, check the length of the message, make sure that the message number is greater than the highest number we've had so far for that agent. That is all okay. Then we should update the state of our agent to store the last message number that was received. Okay, so that's the programming that you need to do. That's what the system needs to do. But then additionally, I want you to consider this point, because the spy master is worried that that design isn't private, and that other people could read the messages. So you need to think, is he right about that? If so, how would you change the system so that you could have private messages being sent into the system? So in terms of what you need to do for the challenge, you need to create an app chain to implement this. Now, because Protokit, is still in early days, and I don't want you to be worrying about a UI or anything like that. So it's sufficient to just create tests to show the various pieces of functionality are happening correctly within your app chain, and then we need an answer to the question about privacy, but you don't need to implement that. I just need an answer for that. In order to do this, the best way to start is with the Protokit starter kit, and from that you can then build up your own solution. That should give you a good start, and then you should be able to build something that will implement this functionality. I also spoke about Protokit quite a lot in the last session, so have a look at all of those notes as well. The submission for that is the same way as usual, and you have a month in which to do that. Hopefully this is all straightforward, but if you have questions, then please do ask. Okay, yeah, we're just a few minutes early, but I'm out of things to talk about, so I'll stop sharing there. I hope that was useful for people. I hope you enjoyed that. Just to say, yeah, if there's anybody in London, I think there's an event this evening, so maybe I'll see some of you there. But yeah, thank you for attending this session. I hope it was useful, and I look forward to seeing you at the next one. Thanks, everyone.
Thanks, Lawrence. And I'll say something, guys. Today, Drea with us. Drea is Mina Foundation brand manager, and we'll do something. We all do something together. Drea will explain us. Yeah, welcome, Drea.
Thank you. Does Solomon want to ask his question first before I jump in?
Oh, yeah. He can send the question on Slido, or he can send question to Discord, Mina Navigators chat, and I hope Lawrence will answer him. Yeah. So.
Awesome. Okay, cool. So sorry to hijack this call, and yeah. So thanks for giving me just a few minutes of your time. Like Taha said, I'm Drea, and I'm part of the Mina Foundation marketing team, and I recently stepped into a role overseeing the brand. And I've been a part of the Mina ecosystem for over 3 years now, so I'm really excited to see all of you guys building, and also really excited for this new phase approaching upgrade. So I'm just here because we're preparing a fun community video that we want to share at the beginning of the upgrade process, right before the mainnet network stops, and we want to involve all of you in it as well. So if you're comfortable with showing your face or your name in it, then stick around. We prefer cameras on, even if you have a filter, but it's not required. You can still be like this too if you're comfortable with your name. But yeah, it's a short activity, just like a 1-minute activity. So maybe if you're interested in participating, I'll give you just a few seconds to get ready, and then give me like a thumbs up reaction, and then I'll give you the instructions. Is everyone Yes, you don't need makeup to look beautiful. Okay, cool. So I think we're all ready then, right? Oh, I'll give you a second. Is anyone not ready? I'll wait. Awesome. I think we're good. Okay, so everyone just close your eyes really quickly. Close your eyes and just get in the mindset that Mina's mainnet is approaching, right? Imagine that we're getting close to the hour 0 and that the stop transaction slot is about to be reached. And we will eventually stop the network and begin the 12-hour upgrading process. When I tell you to open your eyes, not yet, you're going to read the latest message from Talha in the chat, and I want you to immediately send the first thing that comes to mind in the chat, okay? Okay, Talha, whenever you're ready, let me know. Send the message now really quick. Okay, cool. Everyone, open your eyes. Yeah, celebrate. Does anyone want to like,
Yeah.
what do you feel?
Yeah.
What do you feel inside in this moment? Do you feel like, oh my gosh, I hope this works?
Yeah, I remember we made similar thing 3 years ago, TGE for TGE, right?
Yes.
Yeah.
Awesome. This is great. That is all I needed. So I appreciate everyone's excitement and joining me on this. I will share the video with you guys all to see if you guys are part of it. But I'm really excited for this journey. And also, I just want to say, like, while I'm here, please always feel free to DM me if you have, ideas about content, ideas about messaging and narratives and social media, videos, blogs, whatever your wild ideas are. Feel free to just message me on Twitter or on Discord or on Telegram. I'm on all of those, and I'd love to make a connection with you all. So yeah, thanks for giving me just a few minutes of your time.
Thanks, Drea. Thank you.
Thanks.
And Mete or Lawrence, do you want to say something, or are we finished the presentation? Okay, so
Yeah, thank you so much, guys. Yes.
thanks. Cool. Yeah, so see you everyone. Thanks for joining us. See you.